Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. Now, in previous few videos we have covered with the theory part. Today I will be covering the practical part related to medicinal chemistry, where we will be going to see the how to carry out the synthesis of 5,5-diphenylhydantoin, which is also known as the phenytoin. This is the common name for 5,5-diphenylhydantoin from a benzyl. So if you have not watched my previous videos related to the medicinal chemistry, you can watch it on YouTube channel. And if you like the content of this my YouTube channel, please like my videos, share with your friends, and subscribe to my YouTube channel. So let's begin our today's session, that is the practical synthesis of the 5,5-diphenylhydantoin. Now basically the synthesis of this 5,5-diphenylhydantoin is divided into the two steps. In first step, we will be going to carry out the synthesis of Benzyl from benzoin. You might be familiar with, because this synthesis we have already performed in the pharmaceutical organic chemistry. Just this first part we will be doing it as a same, which involves the synthesis of benzyl from the benzoin, and later on we will convert this benzyl into the phenytoin. So this is the chemical reaction which involves the oxidation reaction, where concentrated HNO3 is used as a oxidizing agent which converts the benzoin into the benzyl. Here as you see, benzoin is considered as alpha hydroxy beta keto compound, that is the alpha hydroxy ketones, where here there is a presence of the hydroxyl group at the alpha position, and this ketone functional group is present at the beta carbon atom, which converts or which will be converted into the benzyl, which is known as the diketone. So alpha hydroxy ketones are converted into the diketone with the help of this oxidation reaction. So this is about the first step. Now second step, in which we will be converting a benzyl that we have already previously synthesized, or in previous step that we are going to convert it into the 5,5-diphenylhydantoin, which is known as the phenytoin. So here what we are going to do, first the benzyl in presence of alcohol or sodium ethoxide sometimes might be used, that in presence of a alkali and alcoholic solution, it will be first converted into the benzylic acid ester, and this benzylic acid ester will be converted into the phenytoin. So in this particular reaction there is involvement of the pinacol-pinacolone rearrangement. What is that pinacol-pinacolone rearrangement? Just I will explain you while explaining the mechanism. So here just you can remember that this is the second step, the reaction that is involved in the second step, in which we are going to carry out the synthesis of phenytoin from the benzyl, where benzyl is first treated with the alcohol, that is the ethanol, and it will be converted to benzylic acid ester. This benzylic acid ester is reacted with the urea, and it will be converted into the phenytoin. Okay, so these are the chemical reactions that are involved in the synthesis of 5,5-diphenylhydantoin. Now next we will study what is the reaction mechanism involved in this particular reaction. So this is the first step, mechanism involved in the first step, that is the synthesis of benzyl from the benzoin, where here you can see that this is your benzoin, which is known as the alpha hydroxy ketone, to which first we will be going to carry out the addition of the nitric acid. Now here as you see, nitrogen atom is having a cationic form, that is the positively charged, so this will attack on a partially negatively charged oxygen, which is having a lone pair of electrons, due to which there is a formation of this type of a complex will takes place. Now the OH minus ions, you can make correction over here. Here there is a presence of OH minus ions. This OH minus ions combined with this H, and there will be formation of OH2 will takes place. This OH2 is removed as a water, due to which it will be, this hydrogen is lost in the next step. Again in third step, again once what this hydrogen atom is present, this hydrogen atom is again combines with the OH, and it will be converted into OH2 and it will be lost. and due to which there is a formation of this particular structure takes place, and in last step this particular breaking of a bond between nitrogen and oxygen will be carried out, and the oxides of the nitrogen nitrites are formed and it will be converted into the benzene. In this way, oxidation of the alpha hydroxy group, that is the alcoholic functional group, is carried out and it will be converted into the ketone. As you know here that whatever this hydroxyl group that is present in the benzoin, it is a secondary alcoholic functional group, and as you know that secondary alcohols on oxidation they will be converted into the ketone. So this simple reaction is there, that is the oxidation of secondary alcohols. Secondary alcohols on oxidation they will be converted into the ketone. So this is the reaction mechanism that is involved in the step 1, that is the synthesis of benzil from benzoin. Now we will see what is the reaction mechanism involved in the synthesis of phenytoin from the benzene, where we will be carrying out the reaction of benzene in presence of urea, then NaOH, as well as the ethanol, that is the alcohol. So here first benzil and urea in presence of, here you can see these are the starting materials that are used. Benzil and urea, they will combine in presence of NaOH and alcohol to form a intermediate. So here there is a formation of a bond between this carbon atom and nitrogen will take place. Also here this carbon atom will link to this particular carbon atom, due to which there is a formation of this intermediate and 5-membered ring will, or cyclization of that ring will be takes place. Hereafter it enters into the pinacol-pinacol rearrangement. Now what is the meaning of pinacol-pinacol rearrangement? In these types of the reactions, whatever the glycols are there, glycols means what? Those compounds which are consisting of the hydroxyl groups. These glycols, that is the 1,2 glycols, they will be converted into the either aldehydes or ketones. This type of the rearrangement is known as the pinacol rearrangement, in which 1,2 shift will take place. Now in case of this particular pinacol-pinacol arrangement, you can see over here, first what happens, whatever these glycols, that is the hydroxyl groups that are formed due to the addition of H plus ions which are supplied from the alcohol, they will be converted, this OH will be converted into the OH2. This is known as the better living group. This OH2 is lost in the form of the H2O because there is a strong bond between the oxygen and hydrogen instead of the strong bond between the carbon and oxygen. And here there is a loss of this OH2 will take place, due to which there is a formation of a carbocation will be generated, which is nothing but the positively charged carbon atom is formed. Now as you see here, this carbon is electrodeficient, due to which phenyl group that is present on the adjacent carbon atom, it will be shifted towards this carbon atom. This shift is known as the 1,2 phenyl shift. So the phenyl group that is present over here, it will be shifted towards the second position. That's why it is known as the 1,2 phenyl shift will take place. So earlier the phenyl groups were present on the different carbon atoms, but after this step both the phenyl groups are present on the same carbon atom, and again there will be generation of the carbocation will take place, because this carbocation is more stable as compared to this carbocation, due to which it will be shifted towards this particular carbon atom. Now further on rearrangement, this carbocation will shift, it forms a double bond with the oxygen atom to get the stability, and due to which oxygen gets this particular positive charge, which is known as the protonated ketone. Now this protonated ketone will lose the hydrogen atom and it will be converted into the ketone functional group. In this way, the reaction mechanism of the second step, that is the synthesis of the phenytoin from benzene, involves. After the reaction mechanism, next we will be discussing about the procedure involved in the step 1 and step 2. First we will discuss the procedure involved in the step 1, then I will show you how to perform the practical for the step 1, then I will show the procedure for the second step, and then the practical that is involved in the second step. As you know, step 1 is nothing but the synthesis of benzil from benzoin. Now I request you can write down this particular procedure so that it will be easy for you that understand when I will be performing this particular practical virtually. So here in first step you have to place 2 gram of a crude benzoin and 5 ml of concentrated nitric acid in a 250 ml conical flask. Cover the mouth of the conical flask with the long necked glass funnel and heat it on a boiling water bath in a fuming cupboard. Why in fuming cupboard, or why we have to use the long necked glass funnel? Because fumes are produced, that is the evolution of oxides of nitrogen is taking place, and due to which these particular reactions are performed in the fuming cupboard with occasional shaking until the evolution of oxides of nitrogen has ceased. It requires about 1 hour to complete evolution of the oxides of nitrogen. After that, pour the reaction mixture in a 200 ml of ice cold water that is contained in a beaker. Stir well until the oil crystallizes completely as a yellow solid. Filter the crude benzyl at the pump and wash it thoroughly with water to remove the nitric acid. Recrystallize it from the ethanol. Approximately you have to take 2.5 ml of ethanol per gram of that particular your compound. Then report the percentage yield and melting point. Remember, the product that we are getting in this particular step 1 is directly used for the synthesis of the phenytoin in the second step. So this is about the procedure involved in the step 1. Now I will show you how to perform this particular practical if you were present in your lab. Just I will be showing it you in the virtual mode. Just look at the virtual lab and you can see that how to perform this particular practical. Now for this practical we require certain chemicals like benzoin for step 1. Also we will require the nitric acid for the step 1. As you know which are the quantities that are required, we are going to take the 2 grams of benzoin and 5 ml of nitric acid in the your RBF. That is the first step. So here you can see, here also we have kept the apparatus, beakers. Then here we have kept the your pipette to take the chemicals. Also we have used this RBF, tripod stand, burner, and this is your reflux condenser. You can see first step involves the use of the nitric acid. Here you can see that we are going to take this particular bottle of nitric acid with the help of the pipette. We will be measuring the required quantity of the nitric acid and we will be transferring it into our RBF. Then second chemical that is required for this reaction in first step is the benzoin. We will be going to take this particular bottle of benzoin with the help of the spatula. We will be measuring with the help of the balance, we will be measuring this particular exact quantity and we will be transferring it into the RBF. Once we have placed these two quantities in RBF, next we have to attach a reflux condenser and we have to start the heating. Here you can see we are attaching a reflux condenser. Just you have to imagine that you are performing this practical in your practical hall when you are present in a physical mode. Just we will start now the heating of that particular this RBF. We have to carry out the heating for about 1 hour. So after 1 hour, what happens that we have to stop the heating. Then we will remove the reflux condenser and after that we have to add this particular solution into the water, or you can add a water into this particular solution. Here you can see we have taken the water. Now we will be adding this particular water. Once we have added the water, we have to carry out the stirring vigorously, so that after stirring vigorously, whatever the oily benzil is there, that will be whatever the oily benzoin is there, that will be converted into benzil is there, that will be converted into the crude benzil. So in this way we can carry out the synthesis of the benzil from the benzoin. Once we got the crystals of the benzil, next step we have to perform the recrystallization. Recrystallization of benzil is carried out in the alcohol. Here you can see we have taken the crystals of that particular benzil to which we will be carrying out the addition of the alcohol. Then we will start the heating, and once we will start the heating, once the temperature of alcohol increases, it will be converted into the liquid, and as soon as it will be converted into liquid, we will be going to carry out the filtration of this particular liquid as such when it is hot, and once we will filter and when the solution is cooled, and again whatever the crystals of the benzil are there, they will be reprecipitated. In this way we can perform the recrystallization of the benzil. After recrystallization, next step is we have to carry out the determination of melting point of that particular benzil. Once we have recrystallized our product, we have to carry out the drying of that particular product. We can dry our product in the hot air oven at about 40 degrees Celsius. Once we will get the complete dried product, next we have to perform the melting point. You can see this is your assembly that is used for the determination of melting point. This is the Thiele's tube in which we will be attaching a thermometer with your product. Now you know how to perform the determination of melting point with the help of this particular assembly. Now next we will see how to perform different calculations. Here just we will be focusing on the step 1 calculations. As you know, this is the reaction that is involved, or we have performed this particular reaction or conversion where we have converted this benzoin into the benzil. Now we have to calculate the theoretical yield. So how to calculate the theoretical yield? First we have to convert this particular structures into molecular formula. So what is the molecular formula of this benzoin? It is a C14H12O2, and the molecular formula of this benzil is C14H10 and O2. Now once we get the molecular formula, we have to convert it into the molecular weight. So the molecular weight of the benzoin is 212 and the molecular weight of the benzil is 210. What is the meaning of this? If we take 212 gram of the benzoin, it will be converted into the 210 gram of the benzil. Now if you remember, in procedure we have taken the 2 grams of the benzoin. So how much amount of the benzil that we will get, we will consider it as a x. Now with the help of the cross multiplication we can calculate the value of this x. So x is equal to 210 into 2 divided by 212, that is equal to 1.98. This is known as the theoretical yield. Means if we take 2 grams of the benzoin, we will get the 1.9 gram of the benzil. Now further we have to calculate this is known as the theoretical yield, 1.98. Further we also have to calculate the percentage yield. Now for percentage yield we will require the practical yield, means actual amount of compound that we got after performing the practical. Suppose here in this case we got the practical yield of 1.8 gram. Then percentage yield is calculated by formula practical yield divided by theoretical yield into 100. So 1.8 divided by 1.98 into 100, that is equal to 90.90% weight by weight. So this is your percentage yield. Okay, that can be tabulated in the form of the result. Okay, so here we have completed with the step 1 where we have seen what is the procedure behind the step 1, that is the conversion of the synthesis of the benzil from benzoin. Now whatever the benzil that we will get in the step 1, we will be using it as a same for the step 2, that is for the synthesis of the phenytoin. Now we will see the procedure for the step 2. Take 1 gram of benzil, 0.6 gram of urea and 3 ml of 30% aqueous sodium hydroxide in a 250 ml RBF. You can change these quantities because in last step we took the 2 gram of that particular starting material. That's why we have just reduced over here as a 1 gram. So now also here just I request you can write down this procedure in your practical notebook. So while performing this practical, you are able to easily understand this particular experiment. Then we have to add the 10 ml of ethanol to it, and we have to attach a reflux condenser to this particular RBF. Now heat the contents that are present in the RBF on a water bath for 2 hours. Pour the content after the 2 hours. Stop heating. Pour the content into ice cold water in a beaker, or you can just add ice cold water to RBF. Filter, and then you have to add the concentrated hydrochloric acid to make a filtrate a strongly acidic. Once it becomes acidic, then we have to cool down the content that are present in the RBF. Then the phenytoin precipitates out as a crystalline mass. So simple procedure is that just we have to carry out the refluxation for the 2 hours. Now I will show you how to perform this practical if you were present in your lab. Just you have to imagine that you were present in the lab. So just once again same type of assembly that we will be using for this experiment or this step also as we have used for the step 1, where we will be carrying out now the synthesis of phenytoin from the benzil. For that purpose we will require Benzyl as well as the NaOH. So here, as you can see, we will be taking the bottle of 30% aqueous NaOH. We require 3 ml of this particular 30% aqueous NaOH. You can see we are going to take this PPT. With the help of the PPT, we will be adding the NaOH. Then next we have to take the Benzyl. Already we have synthesized the Benzyl, and we will be taking that particular Benzyl as such for this particular synthesis. Take required quantity of the Benzyl with the help of this spatula, weight it and transfer it into our RBF. Next, once we have taken the Benzyl, also we have to take the ethanol, that is the 10 ml of ethanol. With the help of the measuring cylinder or pipette, we can measure this ethanol and we will take it into the RBF. Then also we will require the urea. 0.6 gram of urea is required, which we will take with the help of the spatula. Here you can see we are taking the bottle of urea. With the help of the spatula, we will measure that urea and we will transfer it into our RBF. Once we have taken all these chemicals, we have to attach a reflux condenser to it, and we have to start the heating for this particular experiment. Now we have to carry out the heating for the 2 hours, and after 2 hours, once these 2 hours are completed, we have to stop the heating. Then we have to remove the reflux condenser, and next step we have to add this particular filtrate into the ice cold water, or we are going to carry out the addition of ice cold water to this particular filtrate. Here you can see we are going to carry out the addition of the ice cold water. After this also, once we have added the water, we have to make it strongly acidic with the help of the addition of hydrochloric acid, and once it becomes acidic, whatever the phenytoin is there, that phenytoin will be gets precipitated. Now once we will get the crystals of phenytoin, we have to carry out the filtration, and we are going to carry out the recrystallization for this particular phenytoin. So here you can see this is the assembly for the recrystallization, where we are going to carry out the heating of that particular phenytoin in a particular solvent, like say for example ethanol. Now here, whatever the solvent that we will be selecting, it will be selected on the basis of such a phenomenon that our compound is insoluble into cold solvent, but our compound gets solubilized as soon as we heat that particular liquid. So here you can see that the RBF, which is containing a phenytoin and ethanol as a liquid. Now here we are going to start the heating. Once we will start the heating, and as soon as the solution becomes hot, our solids will be converted into the liquid form. And when this solution is boiled, as soon as it is in the hot condition only, we are going to carry out the filtration of that particular contents that are present in the RBF. Now here we have carried out the filtration, and we will allow this particular solution to cool down, and once it cools, whatever the solubilized phenytoin is there, that will be reprecipitated. In this way we can carry out recrystallization of phenytoin in the same way as that we have carried out for the benzene. Now once we will get that particular pure form of the product, next step we have to perform the drying of that particular product. Again, depending upon the temperature, we can dry this particular compound into the hot air oven. Then we will determine the melting point with the help of the thiol tube. Also we can use the digital melting point apparatus. Now here, after the finishing the practical, we will see which are the different calculations that we have to do. Again the same calculation, just what we are going to do over here, that Benzyl, we have converted this Benzyl into the phenytoin. Again same steps we have to follow, that we have to measure the molecular formula as well as the molecular weight. So molecular formula for the Benzyl is C14H10O2, while for the phenytoin it is a C15H12O2N2. We are going to convert it into the molecular weight. So molecular weight of Benzyl is 210 gram, while the molecular weight of phenytoin is 252 gram. So here we have used the 1 gram of the Benzyl. So here what is the meaning, that 210 gram of Benzyl, when it is used, it will convert it into the 252 gram of phenytoin. So here we have used the 1 gram of a benzyl. So we will consider it as it will be converted into the x gram. So by cross multiplication we can calculate the quantity of x. X is equal to 252 into 1 divided by 210 grams. So it is equal to 1.2 gram. So this is known as the theoretical yield. It is equal to 1.2 gram. Next, suppose after performing this practical, we will get the practical yield of that phenytoin as a 1 gram. Then we will calculate the percentage yield of this particular product by using formula practical yield divided by theoretical yield into 100. So 1 divided by 1.2 into 100, that is equal to 83.83% weight by weight. So this is the percentage yield of this particular phenytoin. Now we have to tabulate our results for step 1 as well as the step 2. Means whenever we are representing the results, we have to represent it in the form of the step 1 results as well as the step 2 results simultaneously for the both. So for step 1, that is the synthesis of Benzil from benzoin, theoretical yield is equal to 1.8 gram, practical yield 1.98 gram, percentage yield is 90%, 90.9% weight by weight, and melting point is 94 degrees Celsius. And for step 2, theoretical yield 1.2 gram, practical yield is 1 gram, percentage yield is 83% weight by weight, and melting point is 284 degrees Celsius. So here we have seen how to perform the practical synthesis of the phenytoin from the benzyl in a virtual mode. So here we have completed this particular practical. Thank you very much. And if you like the content of this my YouTube channel, please like my videos, share with your friends and subscribe to my YouTube channel. Thank you.